Welcome everyone for the first edition of a public webinar, or what we'd like to call as Learn Session. The webinar will constitute of 30 minutes. And thank you for all the attendees for participating in this webinar and patiently waiting till it began. The objective of this webinar is basically for us as an organization. We've been doing security for the last 40 plus years, and the idea is for us to share our experience and expertise in the domain of access control. This webinar is directed to pretty much towards anybody who's interested from an access control standpoint, or it's for any access control enthusiasts who'd like to know about technology in general. So in this presentation is basically for a beginner in access control who would like to know the fundamentals from an access control standpoint. If there are questions that you'd like to ask, please feel free to ask them during the course of the webinar or at the end, and we'll try to answer whatever is possible in the time frame. And if there are questions that we cannot answer during the presentation, we'll answer it by means of an email. Yeah. All right. On that note, let me quickly begin today's Learn session. The topic for today, as most of you already know, is Introduction to Access Control. And before I introduce access control, let me quickly introduce myself. My name is Anand. I'm the Business Development Manager, and I handle a couple of countries in the Middle East. And I'm also a security advisor for end users and consultants alike on security in general and access control specifically. And this is my 5th year at NEDAP. So if there is anybody who'd like to connect with me, please feel free to do so using LinkedIn or using my email address. Let me also introduce my wonderful colleague who's going to do this presentation with me.
Thank you, Anand. And my name is Blazej, a consultant and client manager in Poland. I've been working in access control and security market for over 15 years. I've been with NEDAP for 3 years, and I'm really passionate about new technology in security market, especially in access control. You can catch me on this email address, and I think that we can start this webinar.
Awesome. Okay, thanks, Blazej. So let me quickly move on. Like I said earlier, like I iterated earlier, this webinar is a basic webinar, which means we will touch base on the following topics. First one being, what is access control, or why do we need access control? The relationship between RFID and access control, and wired access control and related components, anti-passback, and last but not the least, vehicle access control. Yeah, so these are the following topics that we'll be touch basing in this webinar. And let's start off this webinar with a question, which is, what's wrong with a key? Because I'm guessing pretty much everybody uses a key to open the door inside your premises. So what's wrong with it? The problem of using keys is that you lose keys, right? I mean, I happened to lose my key a couple of months before, and it's safe to say I had a torrid time with my landlord replacing the cylinder for the key. Yeah. In addition, keys don't leave any trail, which means if I happen to lose a key, or if it goes into the wrong hands, then I can expect some problems as a result of that, and not so good ones at that. Yeah. So keys don't leave any trail. And the most important thing, managing and maintaining keys are a little bit of a pain, because you have a melange of keys and you have different kinds of people who'd like to use these keys, and only certain people needs to be given access to certain keys or certain rooms. Yeah. So managing is also pretty much a big challenge, which brought into picture the evolution of access control, or what we'd like to call it, the solution for some of the questions that we touched based upon in the previous slides. Yeah. And what are these principles? Using access control, you get to know who is inside the building, where he's inside the building, when he's accessing a door in a building on a specific schedule, and of course all of this on a dynamic basis. So if I were to put things in a nutshell, access control gives you who, where, when in a dynamic schedule, and you get to know all this information with probably a couple of clicks or a click of a button. Yeah.
And now let's take a look at the architecture of an access control system and how they perform these three principles which Anand mentioned. So who means the people which have to identify themselves. This is done most often with access cards, but we also see a trend for mobile phone and QR codes. Where is the place where you need to read this card at the door level. The devices at door level are connected to a controller, which is like a small computer and which determines whether the person is allowed to enter or not. At the server level, the authorizations are managed, determining when and where the person is allowed to enter. We'll explain you all levels of the access control system, and we will start with the person level, where we need to identify the person. This is the place where the access control starts by knowing who is at the door. And how access control system identify the person? It can be done by something you have, for instance, by using an access card, mobile phone, or QR codes. But the downside of using, for example, cards is that issue can be complex and people may forget it or lose it. It can also be something you know, for instance, a PIN code. However, it is really easy to give a PIN code to other people or to forget it. Finally, this option is less common. Something you are, biometrical characteristics, can also be used. This is more expensive, can cause privacy issue and can be less user-friendly or slower in some cases. So as you can see, all have a pros and cons, but mostly used are access card and mobile phones. This we will explain into a bit more depth. So what is actually access card? The access card most often based on RFID. What is RFID? I will explain you later. And this access card contains a unique number. That unique number is linked to a person. That's why the access control knows who you are in the system. On the access card, there are actually two numbers, unencrypted number and encrypted number. Unencrypted number is just like serial number, which can be easily copied by using default tools which are available on the market. It's not secure in the other world. So that's why it's common sense that we should use only encrypted number, which provide us encryption in storing and reading this number. RFID allow contactlessly reading of that number without using a battery. It goes as follows. When the card is held in the reading field of the card reader will generate power from this field. By using this power, card will send its unique number to the reader. What is very important, the reading distance depends firstly on the card technology, type, size, and quality of the card reader, and finally on frequency. Anand, could you explain a little bit more about frequencies and how they act with that distances?
Of course, of course. Good point, Blazej. So basically, if you consider RFID, frequency reading distance, it's broadly classified into three different categories. All right. So basically, it involves high frequency, and then low frequency and ultra high frequency. And if you're wondering what is this, at least for people who are hearing about access control for the first time, you can consider this like a language. So if there is a certain technology which is based on high frequency, and if there's a certain reader which is based on the same high frequency reading, then these two readers, or the reader and the credent and the card, will only uh, uh, work in that specific frequency range. So you can consider this as a language that is understood by the reader and the card. Yeah. And talking about high frequency, you can see that the read range varies between 1 to 6 meters, depending again on the card reader and the card type you use. And then you have low frequency, which is a little bit primitive than high frequency, and it can give you little more reading distance, but it comes with some downsides, which I will briefly explain in the slides to come. And last but not the least, which is again pretty much relevant in the times that we live, is ultra high frequency, which is helpful for people and vehicle identification, or rather long range applications. Yeah. Talking about high frequency, just to put things in practice, are the cards that are used by pretty much all the national IDs. You know, these are also called as smart cards. And the reason why these are called smart cards is because it works on open protocol. It facilitates reading and writing, which means these cards can be used to to encode, or rather write data, which means it can have your name, it can have your biometric fingerprints, it can have encryption keys, which can be used for access control. So these cards, or this technology, is scalable, and that is why it's important, at least in this day and age, to employ high frequency cards for short range applications, because it gives you the scalability and the security that is needed for short and long term. If you compare this with low frequency, which are primitive and which are a little bit older as compared to high frequency, it does not provide you these functionalities. Which brings me to the first poll question of the day: how many of you or how many of your clients still use low frequency cards? It is appalling to see a big majority still use low frequency cards. So as a security advisor, I would recommend, if you're a consultant or if you're an end user, to potentially in your newer projects, to recommend using high frequency technologies, such as, for instance, MyFair S-Fire, MyFair, which is open and which also facilitates reading and writing. Uh, uh, and and also for the entities who are still using proximity, you can always, for the entities who are still using low frequency, you can always do a migration plan, wherein you can slowly migrate your cards to high frequency in order to potentially help, uh, uh, potentially have these benefits from a security standpoint. Yeah. Now we looked at high frequency and we looked at low frequency. Now let's look at the UHF bit and have this image in your mind, guys. I'm going to show you a small video, which is again very relevant in this day and age. Have a look at this video and I'll explain what UHF can potentially give. What you saw in this video is the application of ultra high frequency for people identification, which means if you have a door wherein you'd like to use hands-free access control, you can use this technology in a certain way to get access inside the door without actually physically presenting the card to the reader. Yeah. And if you're wondering, all right, Anand, you just said that frequency is like a language, and that a specific reader can only read a specific frequency range. How can I use two different technologies in a specific reader? What would be a solution? Because I don't want to use two cards. For the people who are thinking on that, from that standpoint, the answer to that question is this: what you can do is, there are certain cards called combi cards, which facilitates having two technologies in one single card, which means you use one card from a long range standpoint to enter inside a building if you have a UHF reader installed there, and then you use the same card inside the building to present it on your short range or rather high frequency readers. All right.
So, as we mentioned before, we can use smartphones as an identifier. Smartphone has been widely used for access control systems since Bluetooth Low Energy and NFC were developed. And it's a great replacement of the access card because it removes the hassle and cost of issuing of cards. What's more, also the chance of someone forgetting their phones are smaller than a card. And one more thing, for visitors, for instance, smartphones can also be very handy by presenting QR codes displayed on the screen. Okay, how it works? Firstly, the phone needs to have an encryption ID number which is stored in the phone memory in the safe place. This ID number most often is received from the cloud, which is provided by system provider. This encrypted ID number can be sent to the card reader using NFC or Bluetooth Low Energy or be transferred using QR code. Of course, the card reader needs to be able to reading those signals. Now let's go back to identification. For some reason, use-only identification is not enough to secure entity. So then we need to verify person. As said at the beginning, identification is based on something you have, know, and are. Verification is done by combining any of these three, are, have, or know. What is more, verification measures can also be turned on only outside office hour, when there is a fewer social security. Now it's time to move on to the device required at the door, to the second layer of architecture of access control system. We'll discuss the most common configuration and ways to lock doors. However, there are always exceptions possible. Firstly, we have to distinguish the secure and unsecure side of the door. The secure side is the secured area, the unsecure side is the other area. At the entrance of the building, this is quite clear. The area in the building is the secure side. The outside area is the unsecure side. However, also within the building, each door will have its secure and unsecure side. If we go deeper, we can see that all unsecure side of the door, the access control system needs to be able to identify the person, read the access card, phones, or QR codes. At the secure side, it needs to allow for egress in normal and emergency situation. For instance, no reliance on the power or data. The door needs to be locked, and the status of the door needs to be monitored, because if the door is open, anyone can enter. To avoid this, an alarm is generated if the door is open for a long time. And now I will give you a floor to Anand, who will tell you a little bit more about wired access control system.
Thanks, Blazej. So if you categorize access control broadly, then you can consider access control as wired and wireless. Now what we're going to see is wired access control. And in wired access control, if you look at the data flow, it works in the following manner. So you have a card reader connected to the controller, and the controller in turn connected to the server. Like Blazej mentioned at the beginning, controller is basically like the brain of the access control system. So it takes the decisions. So what happens when I present the card is that the information is sent to the controller, and the controller, of course, is connected or is in sync with the server, which basically receives the information, and the controller takes a decision depending on the authorizations that is given to a person, or no, yes or no. Yeah. And if you look at the components involved in wired access control, and I'm going to take the same example that Blazej used of secure and unsecure side. And just to make things easier, your unsecure side is basically your entrance. Yeah, which is, so if you're sitting inside your room, the side that is opposite to you, which is on the other side of the door, is your unsecure side, and the door that is facing towards you is your secure side. So what are the components that you place in this particular scenario? On the unsecure side, first of all, you'll have a card reader, right? And if you're talking about a card reader, you will have different types of card readers. You can have a smart card reader, you can have a QR or a smart card or NFC reader, which means if you're talking about turnstiles wherein a visitor is going to come in, he can get a QR on his mobile phone and seamlessly get access into the building. So you can use in those kind of situations a QR reader. And of course, if you're talking about high secure areas, you use PIN plus smart card reader, or what we would like to call it as two-factor authentication readers. It basically means two steps. So if somebody gives the card to the wrong person, or somebody has access to the card, he still needs to know the PIN to get access into the particular building or particular door. And of course, for areas like IT rooms or IDF rooms where security is of essence, you use biometric reader, which means no matter who steals your card, you still need the biometric information to get inside the door. And last but not the least, you use UHF readers for hands-free access control. All right. Is that all when it comes to readers? How do you, and again, how do you interface these readers with controllers? You interface them using open standards. And if you're wondering what these are, you can use a simple analogy of a computer with mouse and keyboard. Open standards facilitate the readers to communicate or give input, or can be used as an input to connect to a controller, like your keyboard and mouse to a CPU. And there are two contemporary standards that are used. One is VGUN, which is pretty much predominantly used across, and the standard that is now or that is into existence pretty recently is OSDP. Yeah, and before I go on to explain the differences and advantages between OSDP and VGUN, I come to the second poll question. How many of you are aware about OSDP and the potential advantages that you have with OSDP? Can you answer this, please? That's nice to know that a large section of the audience knows what is OSDP. And for the people who do not know or who'd like to know, I will explain in a nutshell what it means. OSDP means bidirectional communication, which means that information can be sent in two directions. VGUN only supports one directional communication. So you'd be wondering, what does this mean in practice? Basically, if you use OSDP and if you're communicating with a controller, the information that is sent from the reader to the controller is encrypted. So if you have, or if you try to snoop the information, you will not be able to do it. However, in the case of VGUN, you can always get some or retrieve the information or retrieve the binary data that is being sent from the reader to the controller and use it in malicious ways. And to top it all, if I cut the cable between the reader to the controller, OSDP will get using OSDP, the controller will always get to know, oh, something is wrong with the connection. However, in VGUN, because it doesn't give feedback, there's always limitations in that. Yeah. So moving forward, I would recommend using OSDP as a standard, guys, because it's not a standard that is owned by a certain manufacturer. It's a generic standard that I would recommend to use in your projects. All right. On that front, let's move on to the other components, because it's not just readers that you're going to use. You would also be using on the secure side a mechanical egress. So if you want to open the door, you use an egress to open the door from the secure side. Or again, very relevant in this day and age, you can use a door sensor, which means the sensor will read your information because it might be an IR sensor and you can open the door. Or you can use again a card reader if you'd like to know the exact count of people inside a door, because having card readers gives you the information that is required in a particular zone, particular area, particular building. And last but not the least, you can of course use request to exit, which is a standard exit button that you press and the door opens. Yeah. What happens if you're stuck inside the door? What do? You use an emergency exit button to get outside the door in the case of emergency. And is that it? Of course not. You can have the best of systems, but if you don't have a lock, what's the point of having an access control system? So you need what you call different types of locks depending on the type of door. If you have a glass door, if you have a double door, if you have a single door, depending on the area, you need to choose the right kind of lock to go in what we'd like to call in the access control world an output. And if you have door monitoring doors, so in every building you would have emergency exits that needs to be monitored in the case of an emergency, and these do not typically or should not have a lock because it's an emergency door. However, it also poses a security threat. So you need to have a door monitoring contact to monitor whether that particular door is open or not. All right. These are the different components that you typically use in a wired access control system.
And has just explained you the classic door configuration, but there are also another form of wired access control, the turnstile. Turnstile and speed gates are applied to make sure that one person can only pass at one time. To avoid tailgating, you can either have a card reader on one side Or if you also want to know whether a person already left the building or zone, you need the second card reader, for each direction one. At this place, it's not recommended to use, for instance, verification, because it can decrease the speed, which is very important in this kind of devices. A turnstile may prevent tailgating, but it doesn't prevent the situation when two people entering a building using a single badge. This could be as simple as an unauthorized people passing their badge to their colleagues who have forgotten their badge. Anti-passback prevents people from providing their access card to someone else to go through the same gate. Anti-passback is often used in conjunction with access control. A system with anti-passback notice when an access card is being used that has been used already to enter a zone or building, it then should be no longer able to use this badge to enter the building until it has first exited the facility. This is very important features in modern buildings. And up to now, we have only been talking about in-file person and normal doors. But usually, an office building also has a car park, or there are other vehicles that need to be identified, such as forklifts. This brings us to the last form of wired access control, which is car gates. I hope that you remember the chart with the different reading distances. There are the fourth technology called active long range. The first three are used for person identification, whereas the latest two are dedicated for vehicle identification. Vehicle identification can be done by many technologies, for instance, microwave. Microwave technology uses battery-powered tags, and it's therefore able to provide a much more reliable long-distance signal. Moreover, it can be secret channeled. This technology is really useful if you want to make sure to read only those cards, for instance, in the certain lane. Another technology is UHF, which also allows read tags up to 10 meters, but with less reliability, as the UHF signals can be easily distorted, for example, by water or snow or our body. UHF tags doesn't use the batteries. Last but not least, the number plate is also a unique number and can be used for identification of vehicle. The advantage is that you don't need to distribute tags, making this the cheapest option as well as the easiest to implement. However, it's also the option with the lowest level of security. It is also possible to use someone's number plate or just copy it. Another downside is that out of every 100 cars, a third number will not be read correctly, and it means you will need someone to open the gate for you, for example, receptionist or guards. That's why for a fixed group, microwave or UHF is better, whereas NPR is really good for visitors. This is all from my side this time. Anand, could you recap this session briefly?
Of course, Blazej. So if I summarize this session in a nutshell, gentlemen, we looked at why we need access control and the fundamentals of access control, the relationship between RFID, read ranges, and access control, wired access control, and generic components involved in wired access control, anti-passback, and last but not the least, vehicle access control. Yeah, and and we have additional soft topics which start with wireless access control systems, additional security measures, which means we are going a little more in depth than the presentation that we saw today. Cabling fundamentals. So if you're wondering, okay, nice, but we'd like to know how the connections work, we're going to touch base in the next presentation. Powering, and of course, access control server and the basics. So just to be clear, this is just the preface of what's going to be, let's say, an advanced presentation that's going to come up in part 2, wherein we would touch base on other topics. Because of time constraints, we decided to do it step by step, gentlemen, yeah, and ladies. So I think it's time for Q&A. We've got a little bit ahead. Actually, we promised for 30 minutes. Now it's 34. So we'll make it very brief. There's a lot of questions pouring in, and we'll take a couple of questions for the time being. All the other questions we will get back to you probably at a later point in time by means of an email. So I'd appreciate if you can also share your email addresses for the people who have asked these questions so that we can get back to you. So let us take a couple of questions for the time being.
Yeah, and we have one of them. How access control can act with this Corona situation right now, which we can see in every country all over the world. And we have some information about that. For instance, we can use temperature sensors, which has, for instance, the equipment with IP-based output. And thanks for that, we can connect this IP sensor, IP temperature sensor to the controllers of access control system, for instance, and manage which range of the temperature are able to allow to enter to the building and which not. So of course, it's also possible to generate some reports, how many person entered the building with which temperatures, for instance. It's also possible. There are a couple of more. Uh, for
Yeah, I
instance,
see a couple of more questions. Yes, I see Sujit asking, hi, if I need to use the UHF and HF, what kind of card we need to use? Like I mentioned during the presentation, Sujit, you can, of course, use a combi card. So this would provide you the advantages
yeah,
of using both technologies in one card. And there's another question where Vikram is asking, can we have a combi card with all three technologies in place? In theory you can, Vikram, but that will affect the performance of the card, because there would be I mean it is recommended only to use two technologies in one card, because you cannot compromise performance by having three technologies in one card. We've had experience in the past, and I've dealt with clients that has not worked out very well. So I would recommend to use two technologies. And one last question from Anand Vasudevan, wherein he's asking, will the UHF reader work with non-NEDAP tags? Yes, it will, because we are talking about open protocols. But bear in mind, Anand, that the performance will also be affected by the antenna that is used in these tags. So if the tag that you're using does not have, let's say, the size of the antenna is smaller, the read range or the read distances is something that we won't generally guarantee. Yeah. So keeping in mind our time, I think I've taken 5 minutes for the questions, everyone. So if there are additional questions, please drop in your email addresses and we'll be getting back to you. Thank you for attending this one. Thanks.
thank you very much from my side. It was also a pleasure to share this knowledge with you all.
Thanks,
See you
Blazej.
next week.